So there, I've started recording. Okay. So our topic for today is gradient boosting machines using H2O in R in Google Colab. So it's a little bit it's sort of a mouthful, but the what do you call this? That's our topic. No? So okay, so again, I'm Joe Brillantes. I co-organize the R Users Group Philippines, and then also I lead the data and analytics team um, for a multinational or a transnational dairy company called Friesland Campina. No? So here in the Philippines, we are known for our brand called Alaska. Okay, so let's start. Okay. So later on, I will also be sharing with you this notebook so you can try it on for yourself. No. So there. You might also see what do you call this? A logo of Dyson because I also worked with Dyson several years back. So okay. So let's talk about. I'm not sure if you guys know about H2O or the H2O.ai. So they do have a website, no? So uh, we can show you their website here. So H2O.ai. So this is the product, no, that we'll be using. Um, when I started using this, no, when I started using this, well, um, they didn't really have large language models, I think, before, no. So now I think they have large language models also now, no. So yon. So that's the product, no. Okay. So why did I start using this, no? So normally, no. So normally when you use R, you would always be limited by the what do you call this? By the RAM. No? So or by the yeah, by the memory of your computer, no. So that's one. So I would always hit the limit of the memory of my computer, especially if I'm processing large amounts of data. So when I was in Dyson, I was actually in what do you call this in manufacturing analytics. So we have a manufacturing line. It produces a lot of data, and I would always hit the limit. No, so that's one. And then also with other companies, also I've always hit the limit with the RAM. So that's one. The other one is also, even if you have, like, for example, multi-core machines, no, so especially now we have multi-core machines. Normally, the default of R would be just a single thread. No? So it will just only use one, what do you call this? Uh, uh, one CPU, no, or one core. No? So even if, for example, you have, for example, I think the usual machines right now would have 16 gigabytes of RAM, but it will be divided, for example, into four cores. So each core would only have 4 gigabytes. So if you're not going to use anything in R, you would actually have that, no? So you would actually be using, even though your computer would have 16 gigabytes, it would only use 4 gigabytes without, if you're not going to do anything, if you're not going to tell it to multi-thread. Okay. So that's the history of why I was looking uh for for what do you call this, for products, no, that was easy to use. No, it was easy to use to set up. It's yeah, it's easy to use. So and H2O is one of those products that were easy to use for me. Okay. So also it's open source. No? So it's open source, so that's nice. It's in memory, so it's quicker. It's distributed, no? So that's why it's multi-threaded. And then if you use their platform, it's also scalable. No? So that's one. You can actually deploy the machine learning models that you have trained into their platform, and then you can use it. They have what do you call this? They have a way of deploying. No? So that's one. Pero it's not the usual. My preference, for example, in deploying machine learning models is through REST API. So for H2O, how they deploy is something different. I think they call it Mojo. No? So there, but still it's easy to use. Okay. Um, So also it's allows building of machine learning models on big data. So that's what we're going to, well, big data quote unquote, but we'll what do you call this, I'll demonstrate that it's easily productionalized, so, or productionalization of models in an enterprise environment. Again, if so their product, so the H2O is open source and therefore it's free, but the platform, if you want to productionize it, if you want to use it in an enterprise environment, they can set it up for you. So that's how they make money. So by setting up the enterprise environment, making sure that it's protected, the networks and all those things. But the what I will be demonstrating is you can actually use it and it's free. So okay, and then the core code is written in Java, so that's why it's quicker, than R. Uh, and then, but they also have APIs in R and then also in Python. No? So, and then it's quicker because also in terms of yung data, they use key value store. No? So a lot of our what do you call this, SQL no server or serverless SQL databases right now are actually based on key value store, so that's why it's also quicker. And then of course it's based on the MapReduce framework, no? So from yeah, from Hadoop, no, so it's based on that framework there. And that's like I've already said, it's multi-threaded. Data is read in parallel and distributed across the cluster. So these are these are for someone who models, no, meaning creates machine learning model. It's easy to use once it's been set up. Okay. So there. So that's the product, no. So the H2O dot AI. No? So also so they have several products, no. So they have H2O3, so that's what we'll be using, no. And then again, they also have a separate product for the large language models or for the generative AI. So it's separate, no. So for this specific um for this specific what do you call this demonstration, we will just be using the H2O dash 3. So these are what is included in H2O dash 3 or H2O3. So it has the classical regression and classification model, so generalized linear models, Cox proportional hazards for modeling time to event, and naive-based classifiers. It has yung tree-based regression and classification models like gradient boosting machines, which we will demonstrate today. XGBoost, meron din. Distributed random forest. They have deep learning for here for this specific product. They have deep learning pero feed forward artificial neural networks lang, no. So and then they also have stock ensembles. They have unsupervised learning algorithms, then aggregator, generalized low rank models, and principal components analysis, k-means clustering. And then they also have others, no. So quantiles, early stopping, at saka word to vec. No? So those are the models that are included in H2O.ai or in H2O3. Ayan. Okay. So before we proceed, I think there is a question. It's H2O an overkill for a serial setup. Can you elaborate more on this one, Oliver?
Okay, hi. As far as I can, as far as I understood, when you have HPC, most of the setup is um, cluster and it's using NPI.
Mm-mm.
So I'm thinking if H2O can also help in speeding up um, algorithms if it's set up in a serial, like just one node but multiple cores.
Yes. So sa experience ko, yes. Um,
So it can be set up. Okay.
mm-mm,
Because that's my
yes.
setup currently right now because uh, the R package that I'm using, it doesn't have MPI parallelization. So it's just multi-core parallelization.
Yun. So, uh, pero sa akin, yes. So, sa experience ko, yes. Kasi, rare naman din, kunyari, within companies that you would actually have access to parang clusters, diba? Especially if, what do you call this? If, um, the company is not parang, an AI or an analytics company, diba? So, yun. So, rare sa experience ko that you would have actually access to a cluster. So, normally, you can spin it up, pero, what do you call this? You need approvals, you need a lot of them, pero so, ayun. So this one helped me. Okay. Sige, thank you no for that question. Okay. So let's talk about naman gradient boosting machines. Ayan, gradient boosting machines. Okay. So gradient boosting machines, what do you call this? So they're tree-based algorithms, no? So very similar to random forest or to XGBoost, ganyan, or to carts, no? They're very similar to that. So pag-usapan muna natin ano ba yung why would you use GBMs? No, so one is if for example you do not want to assume linear relationships between variables, no. So this is an example of it, no. So so kunyari yung function mo is like just it looks like a parabola, and then the blue function is the fitted one from GBM. So makikita nyo medyo jagged siya because kasi tree-based siya. No? So, yun. So, kaya medyo jagged siya. Pero it captures the relationship, the non-linear relationship quite well. No? So, yun. Hindi lang siya ganun ka-smooth, pero it does capture it. And then also, at least from experience, or hindi mo from experience, from, what do you call this? From, uh, I forgot the term, no. Pero from the people's experience, no, for those people who have been using gradient GBMs, no. So um, it's more accurate, no. So that's what they're reporting. It's more accurate in terms of prediction, no. Pero why it's more accurate, people do not really know, no. So pero it is more accurate, no. So at least that's the experience that people have been reporting. Pero again, people, at least you can correct me if I'm wrong, pero I haven't seen parang an explanation of why it can be it is accurate, no? And then also just like other machine learning models, no? Kasi of course with machine learning models, yung difference niya from classical statistical models na what do you call this? You can interpret yung mga coefficients. Pero of course, kapag sa tree-based models, you do not really have coefficients. So the best thing that you have is the variable importance, no? So it would give you which variables are predictive or can really help in terms of the prediction. So yun. But it's so yun na yung pinakamalapit in terms of yung interpretation of why this model works, no? Yun. And then say again, no, often perform better than random forest, bag classification and regression trees or carts or even single carts, no. So yun. Okay. So how does it parang intuitively how does it work, no? So okay. So kunyari for you have the first iteration. So uh yung GBMs, they also call it parang additive model. So it's tree based and it's additive. No. What does that mean kapag when we say additive? No. Okay. So kunyari on the first iteration, you have a data set, and then the green ones here are the ones that we are trying to predict. No. So it will go into a model. So ito yung tree-based na model. It will train, or hindi man it will train, pero you will train a tree-based model and you come up with a prediction. Of course, there are, what do you call this? There are errors, no, from it. No, so, and then the errors would go here, no. So you have a data set, and then you would attach the errors onto that data set, and then you will try to fit a model to predict those errors. no, and then it will come up with a prediction, and then again it will have another, and then it will have again another error, no, based on the model 2, it will have those errors here, and then you attach it again to your data set with with the features, and then you model another one, and then you come up with a prediction. So and then again you would have a set of errors, and then so on. So here you would actually, you would even see no, na what are the hyperparameters that you would need to decide. So kunyari, how many models do you want to have? Ganyan, no? So those are one of the hyperparameters that you have. And then how does it improve the prediction, no? So essentially it will have a prediction one, and then yung what is the prediction of the error, and then another prediction of the error, and then it will just sum it up, and then it will come up with a prediction. So ganun yung ginagawa nung intuitively, that is how gradient uh boosting machines work, or boosted machines. Yeah. Okay. And then if you want to understand more about it, no, so I've also attached a lecture from Trevor Hasty in terms of yung gradient boosting machine learning. So you can watch yung video. It's a good example, or it's a good example. It's a good explanation of what gradient boosting machine is doing, like even a lot deeper than what I'm currently telling you right now. Okay, so let's head over to using the going to R. No, okay. So here on the first one, I'm just installing H2O. So that's the H2O here. There's the R curl and then the JSON light. No, so yun lang. So I'm just installing H2O here. So and then after that, no, okay, so because it uses Java, no, if you're going to use it on your machine, kunyari on your personal laptop, um, if you can install different versions of Java. You can also put this on a system environment if you want, or there. Pero sometimes it's easier to just tell, no. For example, if you don't want to uninstall your old Java, and then you just want to have multiple copies of Java in your system, and then you don't want to really mess up your system by what do you call this, by installing several system environments into it, you can just set it in R. No? So in this code over here, um, we're just telling the R which system or which Java to use. No? So yun lang siya. So you just need to um, indicate, no, the which Java binary are you going to use. So you can have multiple versions of Java in your computer, and then you can just choose which one is more appropriate. No? So here, if you run it in Google Colab, you don't actually need to do this anymore. So that's sort of nice. Okay. So and then what you do next is you need to initialize H2O. Okay. So and then that's just it. No, local H2O dot init, and then the number of threads that you want to do. Okay. So well, generally you should also know how many threads or how many processors or cores you have in your computer. So also do not use all the cores of your computer. Kasi if you use the cores of the computer, you cannot use your computer. So it will just use everything up. No. So for your functions, or for this activity, no? So especially kung kunyari, if your laptop is also the one that you use to check your email, chat, ganyan, especially if at work, no. So do not use all the cores, no. So here I think so for H2O.ai, I think, or H2O.ai, for the Google Colab, I think yung usual is just I think I don't know how many cores that they have, pero hindi siya kasing rami ng cores that I have on my computer. So that's why I used two, no. Pero normally kasi a computer would have, sometimes hindi naman normally, pero it would have four, ganyan. So you can use three if you want, and then the one core for the system functions, no, or for the other functions of the laptop. So para maging productive ka rin naman while you wait. Okay. So yon. So once it installs, then it will have this, no. Okay. So so this one is a sample data set, no, that we can use, no. So I'm not sure if you're familiar, pero this is one of those data sets that are quite popular, no. So human activity recognition using smartphones, the data set. So if you're wondering how, diba, sometimes, or like I think our watches now can also do it, no. So pero before, when I was doing this, what do you call this, the phones, they can identify if you're walking ganyan. Diba? So parang sometimes you would wonder how does it do that, no. So parang this one is sort of a what do you call this, a demonstration of how it does that. Okay. So the data set, basically you can download it from here, no. So sa from this one, the um so this one is parang a repository of all the of a lot of data sets for machine learning if you want, or for statistical learning also if you want, pero they also have this, no, the human activity recognition data set, no. Essentially it's a data set that has 10,299 instances, and then it has 561 features. So medyo madami, diba, if you're going to work on it. So and then uh, w- so on our phones we have accelerometers at saka gyroscopes, no. So and then basically they have it it what do you call this, updating preview, what's happening here, it demonstrates, it generates data, and then I don't know where they send it, but or if it's just on your phone, but it generates data. The accelerometers generate data, and that's how they your phones can sort of identify if you're walking upstairs, if you're walking downstairs, if you're sitting, or if you're standing, if you're laying, no. So and now even our watches can actually do that now, no. So yun. And now I think smartphones are smarter now because they can identify if even if you're sitting pero you're riding a plane, they can, 'di ba? They can the phones can tell that now, or if you're in a car, if you're driving, ganyan, the phones can tell it now, no. So yun. And I don't know how they do that, pero most likely it starts with the accelerometer at saka the gyroscope. Okay. So of course, we want to load it on the data, or we want to load this data into well, first and foremost into our muna, no. So yun, so we can load it up there. So we can download the data from here. So this is what the code does, no. So it downloads the file, it's the zip file, no, and then after that it unzips it, and then it loads the feature, no. It loads the features to train X and then to test X. So in the data set, they have a training set, no, so that those are the features, and then also they have a test set, of course, that contains the features, and then for some reason they also separated what do you call this, the variables that you want to predict, or the categorical variables that you want to predict, no. So that's why it has a chain Y and test Y. So after we download it, we unzip it. So this is the unzip, and then what do you call this, and then you put it on the you read it, and then you put it on this variables over here. So this works even in H2O.ai. Actually just what do you call this, ran it parang I think Monday. Yeah, Monday I ran it just to make sure that everything works, no. So also because it takes quite a while for me to run it. So uh yun. So we would be waiting quite a while, or hindi man quite a while, pero we would be waiting a lot if I run this live, no? So that's why I'm not running this live. Okay. Uh Okay, and then here we're just, and then again, it's strange enough, pero what do you call this? So the FWF is fixed with file, no? So it's fixed with, so that's one. Pero I don't know why this file is like this. And then the header names are actually in a different file then. So these are the features .txt, and then yon. So it's space separated, no, and then you assign the features on the, or the column headers, the name of the columns on the variable features. No? So yon. And then, kaya here, I extracted the features and then I assigned the features to the column names in chain X. So and then also the column, that column, the features also got assigned to test X. Kasi yung, at least naman, yung, what do you call this, yung structure ng test X at saka chain X ay similar. No? So yun. And then yon. So, and then after nun, I just unlink the file. No? Okay. And then, because I have a chain set, and then a chain set and a test set, I just combine them, no, so that I can see naman what the data looks like. Here, I also, so that, what do you call this? Um, it can be correctly, kasi all the features are parang numbers, no? So all the features are numbers. Pero of course, the what do you call this? The ones that we are trying to predict are actually categorical variables, no, even though they're represented by numbers, no. So kaya here I just corrected for the what do you call this, for the for the data types, no. So that's why you see here chain set dollar activity, I converted it to as factor, no? So yun. Yeah. So and then this is what the data looks like, no. So it has a lot of features, no, 561 columns yan lahat-lahat, and then there's like 10,000 plus rows, no. So not technically not big data, but it's big enough to what do you call this, to be sort of a pain, no, or at least to learn something from, no. So yeah. And then okay. So and then after nun, what we would need to do is we need to load it to H2O.ai, no, to that instance, no. So yun. So this is what it does, no. So here also we're what do you call this? So kaya well, I I'm it's possible to actually just load it directly to ano, no, to train to H2O.ai, the data that you have. It's possible. It's just that I was just having a lot of difficulty uh to do it, so that's why I did it first on H2O, or not on H2O, on R, and then after that, after I've corrected everything, I put it on H2O. So yeah, mainly just because I'm a lot more familiar with the syntax in R than in H2O. Pero again, it's possible to just do the data engineering, the loading directly to H2O, so that you don't have, so you're actually not doing anything, or not doing anything. You're It's not being stored in the workspace of R. Everything is actually on the workspace of H2O. So, yun. Okay. So, when I did it on my computer, I can also do yung hyperparameter search and cross validation. So that's how I trained it. Pero when I did it on my computer, it took 5 hours. No, of course, if you're going to do this in Colab or in Google Colab, it will not allow you to do that. No, yun, because it will just take long, no. So when I tried it on the hyperparameter search, when I tried it on Google Colab, humihinto siya, so it automatically stops, no. So you need to buy what do you call this, compute, uh yon, so you need to subscribe and buy compute. So pero you can also do this in your computer. So yon. So essentially what this does is that I've emphasized, not emphasized, but I've just said na ito yung hyperparameter. So yung max depth, no, you can try 3, 8, 21. The number of trees, so yung max depth is the depth of the trees. No, you can try uh, 3 levels, or 3 levels, or 8 levels, or 21 levels. And then the number of trees, so how many trees that you want to have. So yung cheese is or how many iterations that you have. So if we go back, yung the number of cheese is this one, no? So yung iteration. So this is the first tree, the second tree, the third tree, the fourth tree, and then yun, and then so on and so forth, no? So depende on how many you want to chain or how many you want to try, no? So here I just indicated that I wanted to try um I wanted to try 10, 50, and then 100, and then the learn rate here. So yun. Yun. So I indicated the hyperparameters, and the H2O dot grid is the training part, no? Uh so ano yung X, so which is basically yung column headers or the features, and then ano yung column ng Y, which is basic the activity, which algorithm do you want to use. So here you can do well, not do, but you can we wanted to try GBM, pero here you can change it. And in distribution, so multinomial, because what do you call this? We are trying to predict six categories, ganyan. So and they represent names, no? So kaya multinomial. And then yung hyperparameters are here. Learn rate annealing. So this one I can't remember why I put 0.99, but it's essentially parang it's a hyperparameter that you can parang you indicate something so that it will stop training, no? So it will not parang early stopping criteria niya. And then what is the training frame? The number of folds is yung if you indicate that, then it will say it's the not it will say, but it will be the cross validation. So yun. So it will have 10 folds in terms of cross validation. Sample rate, the column sample rate. So what do you call this? So on the sample rate is you want parang kunyari, di ba? So i-divide niya ng 10, tapos uh, and then how many do you want in terms of the number of rows that you have? So parang kunyari 80%. Column sample rate, also try the 80% of the columns there. No, kasi yun nga, diba? Parang it will yun. So it will try that. And then yung search criteria is so here is that strategies random discrete maximum 10 models. So para hindi siya continuous, so it will try discrete combination. So 3, 10, 0.01, parang ganun siya. So rather than itatry niyo yung interval na yun kasi mas matagal yun. And then and then here you just specify kung ano yung gusto mo na pangalan nung grid ID. So because the grid ID will also help us kung ano ba yung best model. So okay. So that's the hyperparameter. So pero it's if you want to do it in Google Colab, you have to pay. So yon. So here I've essentially selected yung ano yung best model, and then this is the training part. So this one takes siguro mga 20 minutes in Google Colab, or maybe 20 or 30 minutes, pero it will continue doing it all the way to 100%. Okay. So and then this one over here is yung continuation of this to this, no? So essentially we will look at what do you call this? We will look at which is the best model, and then we will select the best model here. So essentially what I'm saying here is that um, you get the grid, and then you sort it to decreasing order based on log loss. Uh, and then that is the depth grid over here. So ayun siya, yung grid ID. And then kapag may sorted grid ka na, and then syempre 'di ba, yung decreasing yung log loss. So yung best model would be yung first. So yun. And then I assigned it to GP model. Yan. And then now, pero here on this one, kasi this is the best model na, so I just assigned it to the GP model, no. So yun. So and then on the GB model, no, so you can use that as to predict, no. So and then doon na yung pumasok yung test set, no. And then here you can look at the predictions, no, whether it's good ba, no. Okay. So what you want to happen is I said because there are six activities, so 1, 2, 3, 4, 5, 6. I just forgot ko ano yung 1, 2, 3. I think this is walking, yung 1, 2, 3 walking, and then laying, sitting, ganyan, no? So, pero what you want to do is you want to make sure na just like any other, what do you call this, confusion matrix, um, you would want the majority of your predictions to be on the diagonal. So yun. So yun. So parang ibig sabihin lang nun is that yung activity talaga is one and then the prediction is actually one. So uh so there were for yun. So kunyari on the so it was it the algorithm got it correctly for 479 rows, no, or 479 from our test set, no, but of course it didn't get everything, no. So for example, for those that it predicted uh to be one, for example, not for and then some of them they have mistakes, no. So kunyari here, no, it's actually one but the prediction is 2, so there's 29 instances of it, and then there's a prediction of one but it's actually three, so there's 12 instances of it, so parang ganon. So yun. So you're on. So and then here, if you want to tune it pa, then this is where you would play na, no? So which ones? So you on. And then again, you can also display yung variable importance, no? So here it's very easy to display yung variable importance. You on, no? So I wait, sorry. Itas ay. So mahaba siya, it will actually give you all the, what do you call this? All the variable, or because there's 561 variables, so it will try everything, or not try everything, it will give you the variable importance of all the 561 variables, no. So normally I would look at what do you call this, the scale performance, ano lang, yung most predictive variable will actually have just one. So yun, uh so kaya yung scale performance is this one. Pero yun. And then the percentage is parang how much, kunyari this one, the gravity accelerometer, the minimum of it, uh, this variable accounts for. So medyo malaki siya. So 24%. Parang ganon. So this is parang if you're going to interpret yung variable importance, then this is where it, kung kunyari, how would you try to explain yung model, how it uses stuff, then ito na yon, no? So yon. And then of course, yung last na step is you just need to shut it down, no? Shut down yung H2O.instance, no? So just uh, if you're using your laptop, it's not very important. Or if you're using your not H2O.ai, if you're using Google Colab, it's not very important to shut it down. Pero if of course if you're using kunyari your cluster, diba, it's very important to shut it down, kasi if you don't shut it down, then you will continually be charged. Yun. So that's why it's also important to shut it down. And then well, ganun din, even if in your laptop, no, it's also important to shut it down kasi so that it can free up the memory. So ibabalik niyo yung cores uh, sa other processes, or if you free up niyo yung cores. Pero again, wala naman siyang you will not they will not bite you financially if you do not shut it down if you're using your laptop or yung H2O or in Google Colab, no. Especially if you're just using the free tier, no. Pero kunyari if you're using the paid tier, then yon, no, baka maubos yung allocation mo very very quickly if you do not shut it down. Yon. Okay, so that is it. Do we have any questions or clarifications? Wala, tahimik. Any questions? Going once, going twice. Ay, may nag-unmute ng mic. Questions? Ayan, so
Ah,
si Oliver.
Sergio, Sergio
Yes.
Brillantes. So I just have a question. Wait lang. Can you scroll? Yeah, I have more than one questions, but
Sige,
can
sige,
we
go.
go back up, please?
Sige.
So you're using there for the cross validation. It's
Cross
just
validation.
yeah, it's not repeated, right? It's just cross validation because I could see n folds of 10.
Mm-mm.
There's no repeat, right? There's no parameter for repeat. So just 10 folds,
No. Yes, just tenfolds.
10 folds, okay. Because most of the time I'm using repeat cross validation. And I think there's a parameter there. I'm not sure, but there could be a parameter there that we can also put the repeat value. And also, can we scroll down to variable importance, sir?
Yes,
I have a
okay.
question. So it's being ranked. So that's for the explainability, I think, where it's being ranked. What's the contribution of a feature in predicting the output? And it seems to be that the gravity, the first one, is one contributor, but it seems to be like everything contributes to prediction of the output, right? Like the 561. Was that the
Yeah.
original number of features from our raw data? The
Yes.
561.
Yeah.
So all
So
of
it's
them.
560. Yeah. So if you want to, what do you call this? If you want to, for example, scale it or not scale it or cut it, for example, you can.
Okay.
Uh,
I have
so
another
ikakat
question.
mo na lang siya. Yeah.
Okay. Regarding, I'm thinking of because I have read somewhere that uh, the GBM can efficiently select a number of features that can really predict the outcome. Uh, is this the one variable importance, or is there another way to determine those features that really contribute to the prediction in the training, or all of them contribute to the training and predicting the outcome or
So
the
okay.
target? Mhm.
So how I understand kasi how kunyari the GBMs work or the trees, 'di ba? So it will try to identify kunyari for a specific tree, it will try to identify parang and then parang there's a randomized, 'di ba? Parang nira-random niya yung sample,
Selection of
no?
features. Uh,
And then how it parang breaks up the tree is that it will try, hindi man it will try, pero it will choose uh parang the best predictor that separates
mhm.
the ano no or the best feature that separates it a little bit clearly, and then that's how it does it, no. So for the individual trees, not all of the variables are there, parang ganon. So pero kunyari, let's say for example, if you uh so for this example, we just included everything. Pero for example, if you once you've seen the variable importance and you want to cut it off somewhere so that it will be easier maybe to explain or to track, diba? So then you can
Mm.
do that. Yun lang, ite-train mo lang ulit siya.
Ulit siya.
So,
Oo.
mm. So yun. I'm not sure if they have kunyari, let's say after the variable importance, will it also parang kunyari automatically kunyari 'di ba the entire GBM, 'di ba? So and then you have the variable importance. So 'di ba parang there are some algorithms that would actually parang choose what do you call this, which variables parang they have parang a selection of the variables, automatic na siya. So I'm just not sure kung meron siya sa GBM or if this is that feature. Parang how I understand it is that they would have it on the individual trees, pero maybe not on the pag inaggregate mo na or pag na boost na yung mga or na stack na yung trees and then it comes up with a prediction. So uh baka baka dun lang as in ta-try niya talagang gamitin lahat. So pero
Lahat. I
oo.
was
So
thinking kasi if there's a way na it can at least list all the predictors that were used to really predict the training set. So that's what I'm thinking. So
Mm,
that, I mean, if you consider the whole 561 features, that's still a lot. So I'm thinking if it can be reduced to like say 40 or 30, and that could be better, and that would be like explainable, more explainable than considering everything.
well, correct. What do you call this? I'm just not sure of parang if there's an automatic selection of it in this algorithm. So, but what do you call this? They have wonderful resources, or not resources. They have very good documentation naman for the H2O.ai. So, baka meron na. I'm just not sure, right? I'm just not aware of it. Baka meron naman din.
Yes, that's very interesting. I'm really looking into it right now, and yeah, I'll be using it in my future work probably. So that yeah,
Yon. So if you kunyari, so I guess yung what do you call this? The benefit of it is for example, if you want to try yung GBM tapos and then you're looking for what do you call this? Yung easy na kumbaga you don't need to multi-threaded na siya. You're just going to say how many cores you're going to use, ganyan. So parang H2O is parang a good alternate or not a good choice, no. So I think I've tried different packages. So far, I think at least dun some I've not tried all the packages. I'm pretty sure there's a lot more that are available right now. Pero dun sa mga na-try ko before, this one is a little bit more convenient, no? Especially kung if you do not really like me, no, I do not necessarily understand parang how what do you call this? How to control the CPU a little bit more, no? So or mas clinical, no? So gusto ko lang na parang I just need to solve this problem and that's it, no. So yon. So for this specific, so this one of course is a specific use case, or not a specific use case, is a syempre sample yung what do you call this, sample yung data set. But the use case that I use this for is that if you can, so dahil nasa manufacturing ako, what we were trying to do is I needed to build a model that can basically parang what do you call this, hindi naman simulate, parang uh predict, or yeah, predict the yung or capture yung characteristics of manufacturing line, because the goal was to look at yung combinations of the different materials, the specification of the raw materials, so that at the end of the line they would have a good quality, no, of materials, or good quality of products. So they wanted to increase yung yield. So yun yung specific na use case that I used H2O uh, .ai for, no. So and of course I do not have access to the data anymore, so I can't use that. And plus, it's proprietary, so I can't use it. Pero the actual use, so I just tweak the codes a little bit better, or not a little bit better, but uh, tweak the codes to fit itong specific example. But that was the use case that I used it for. Okay, I think we have like questions, some questions on the chat. Is the notebook available on GitHub? No, but it's available on Google Colab. So I'll share the link to you later on. And then or on what do you call this? Or on Facebook, no. Um and then Joma has a comment. Individual trees, then aggregate yung computation. Wait, kailangan mong explain to Joma a little bit better. Ano yung comment mo?
I mean yung sa variable importance na kung paano nakukuha, ayun. So, from individual trees, so ensemble siya 'di ba minsan or
Oo.
for every boosting na nagaganap. So, yung computation nung ano, is kung ano yung parang factor nung variable na yun for that particular leaf or node, tapos i-a-aggregate niya overall, ayun. Ganun yung alam kong ano niya,
Oo nga, yun.
importance.
Well, that's how generally parang I guess yung ano, 'di ba, GBMs work. Pero baka may tweaks kasi na rin with the algorithms that they have. So baka yun lang. So yun. Okay. Any other questions that you guys have?
Let me add a question, Sir Brillantes. Yung data set is wala siyang ano no, wala siyang missing po na observation. So complete po
Yeah.
siya. Okay. Kasi
Yep.
in reality kasi, I mean, in real world, yung mga data, marami talaga siyang missing. So, hopefully, may mga sessions ka po ng mga how to deal with missing data, yung imputation, tapos yung effect ng mga different algorithm for imputing missing data set, ganun. And then,
Mm.
probably which one's better. Kasi, I mean, if you have data set that have missing values, instead of removing that whole rows that have um, NA or a missing value, then you do imputation instead, so that you can still use
Mm-mm.
as much observations or rows that you can use for modeling. So
Yeah, correct. Pero merong mga algorithms din. I'm just not sure kung GBM is one of them. Pero there are algorithms also out there na machine learning tree-based algorithms din that they tolerate missing.
yeah, I think
So,
GBM does. I think
okay.
GBM can tolerate missing data. So, but I'm just thinking that if we can like because if you want to use a different model, you still need complete data, right? So
Mm-mm.
is it possible that we can, I don't know, if we can use GBM to fill in those missing data, or uh, probably you have to do a separate imputation for that matter. If you want to use another modeling algorithm other than GBM, because yeah,
Okay.
GBM indeed can tolerate missing data. It can still
Okay.
run without any problem.
So for example, so normally when you have missing data and so hopefully not a lot of them, pero if you have for example missing data and then you feel na syempre it's a waste, diba? If you're going to just throw out specific rows just because one value is missing, diba? So normally there are algorithms that tolerate missing data so you don't throw it out. So that's one. I think mga tree-based algorithms are a little bit more what do you call this, are a little bit more tolerant of missing data. The other, so if you really do need to impute data, uh, what I would recommend, there's this package in R called mice. So mice stands for what do you call this? I forgot. Multi something imputation by I forgot what it's called, but it's a multivariate imputation and then the C and the E I forgot. But what do you call this? It uses so it's different imputation techniques, no? So pero that one is a little bit more I guess more a little bit more nuanced na no. So yun. So yung first recommendation ko is that try to use algorithms that are a little bit more or that are tolerant of missing data. So that's one. But for example, if you want to use algorithms that are not tolerant of missing data, the one that I recommend, there's an R package called mice that would actually do multiple okay. So it's multiple imputations using chained equations is what MICE stands for. No, so uh normally and it's not ano naman, not a criticism naman of what do you call this of uh machine learning. Pero normally how they would impute it is they would what do you call this? They would use averages or they would just use put zero there and all those things. So once you do that, kasi parang if you have different types of, or hindi man different types, yung usual na imputations na lagay na lang natin yung average here or lagay na lang natin yung zero or whatever it is or median or whatever, you're changing actually the distributional property of the data. So yon. So normally it's not good practice. Yung how they're teaching imputation for beginners is not really good practice. So so what I would recommend is you look into yon multiple imputations using chained equations. Yon because it will using that algorithm parang you will somehow preserve yung distri- distributional property no nung data, no? Pero yun. Pero again, what do you call this? Kung hindi tolerant yung yung algorithm na gusto mong gamitin for missing data. Pero normally, what I would recommend is try to use algorithm that is what do you call this? Tolerant of missing data. Yun. Okay. Any other questions that you guys want to ask? Going once, going twice. Okay, so yun. So that is it for this evening. Let me just stop my recording. And then